Greetings. We are going to look at two-way frequency tables. I have an example here. And this one is with the scenario that a math department has taken a survey and they're trying to determine who is going to attend a Colliquium. And so they've surveyed professors and graduate students, and they found that 6 professors plan to attend, 13 graduate students plan to attend, for a total of 19. They have not attending or not planning to attend 24 professors from their department and 35 students from their department, for a total of 59 not attending. If you add these two together, we get 78 total people are in this survey. Across here, we have 30 total professors that were in the survey, and across here, 48 total graduate students. Again, this totals to 78. So you can read the table this direction or this direction, being the two-way frequency table. There's a modification that we can do to this as well and create another type of table. But first, let's talk about some parts of this table. These interior boxes here are known as the joint frequencies, and these boxes on the outside, which hold the totals, are known as the marginal frequencies. The number in a category in ratio to the total number of observations is known as a relative frequency. And that brings us to a modification that we can do to this table, is we can turn it into a relative frequency table by taking all the numbers and dividing them by this number. And so I'm going to go ahead and go through and do that. And so we can see these relative frequencies in here, and this gives us the look of a probability. And we see down here in the corner that this will be 1. We're going to ask a couple questions and see if we can answer them. So the first question is, find the probability that the person is attending the Colliquium given that the person is a professor. So this is a type of probability where we know one thing has occurred, and knowing that one thing has occurred, we want to answer the question about the second thing occurred. So we are looking for the probability that someone is attending given that you know they are a professor. And so this is going to be the probability of attending and professor divided by the probability that they are a professor. And we're just going to pull that information from these relative frequencies. So attending and a professor is this box right here. So this is 6/78. And then the probability that you are a professor is 30 out of 78. And so when you divide this out, you get 6 out of 30, which is a reducible fraction. 6 goes into 6 one time, 6 goes into 35 times. So we have 1 out of 5, or about 20%. Exactly. All right, so the next question that I want to ask is, determine if Colliquium attendance is dependent on being a professor. Again, we are going to use our chart here. The first thing that we're going to do to answer the question, is something dependent, is we are going to assume that they are independent. And we're going to use the frequencies that we have here and multiply them together, since independent probabilities multiply together. And then we're going to compare that to what we actually have. And so the question is attendance dependent on being a professor? So we're going to look at the probability that you are a professor. So that's 30 out of 78. and we're going to multiply that by the probability that you're going to attend the Colliquium. And there's some reduction that you can do in here because this is a reducible fraction itself. And then looking on the diagonal, there are common factors between 30 and 78. And so this is much reducible. And when you multiply these out, you are going to get that it's approximately 0.093688 and so on. And so this is 9% or close to it. If we look at the actual value here, there are 6 out of 78 that plan to attend. So 6 out of 78. If we divide that, we get 0.076923. If this was an independent probability, it should match this. It is close. We have 9% and about 8%, but it's not exact. In a question like this, you would want a better statistical test to be done so that you know that your results are statistically significant. You'd probably want to do a hypothesis test. To answer this question, if you're going to strictly look at the numbers without assuming that there's any kind of error in here, they don't match. This is independent. Since they don't match, we would say this is not an independent, which means it is dependent. So we would say that attendance is dependent on being a professor. And being that you get that result, looking at these numbers, you probably find that being that you're a professor, you probably didn't attend as much as the graduate students did, considering our graduate students are attending at about 30% and only about 25% of our professors are attending. So that would be one inference that you can make. And that's where this is leading into, is inferential statistics and probability. Cheerful calculations.